Good afternoon. Hope everybody had a good lunch. So, what I'm going to talk about today is dielectric breakdown model for lightning. Hope this is working. Yeah. So, lightning is a very dangerous natural phenomena that can cause a lot of damage to whatever it strikes. So. And before I come here, it was not known to me that this is a very dangerous phenomenon. It killed like 5,000 people in Egypt in 1994. So I was interested to read about it. So I'm going to talk a little bit about this phenomenon today. So, so the content of my presentation, I'm going to give a little bit of historical overview for investigating the lightning, and I will talk a little bit about lightning, and then I will classify lightning into two important categories, and then we will give some examples for a very demonstrative lightning strikes, and then we will talk a little bit about creation mechanism for lightning in the dielectric model. So the first attempt to investigate lightning was in 1753, and has been investigated independently in France by Thomas Francois and Dielectric, and in the United States by Benjamin Franklin. So what is lightning? Lightning is, in our model, is an atmospheric breakdown for the dielectric atmospheric breakdown or electrostatic discharge. The lightning bolt travels with a speed 220,000 kilometers per hour, which is very fast, but it it's not as great as the speed of light, of course, and the temperature reaches around 330,000 Celsius. And the distance the bolt travel depends on its power. So the more powerful the lightning bolt, the longer it travels. So according to this, we can classify lightning into two important categories: negative lightning and positive lightning. Negative lightning mainly occurs by transformation of the charge from the clouds. The clouds is the lower part of the thunderstorm and the ground, and the current is around 30 to 120 kiloampere and carries a quantity of charge ranges between 15 to 350 coulombs. The positive lightning is created in the upper part of the thunderstorm. And this is why, because it travels very long distance, because it's very powerful. So the current is around 10 times the current in the negative lightning. So some example for lightning in 1660, lightning struck a gunpowder in Osaka in castle in Japan, and the explosion set the whole castle on fire. And in 1970, Orlando radio transmitter got struck fire, and this struck fire destroyed the basement and led to its collapse. And in 1994, lightning struck fuel tanks in Egypt, and led the death toll was around 500 persons. And most of them were children. So let me talk a little bit about the creation mechanism of lightning. What we know now about lightning is the condition the condition that are necessary for producing lightning, but it's still a matter of debate the exact mechanism of which lightning occurs. And our model is assuming that lightning can occur by a dielectric breakdown in the medium, when the electric field between the cloud and the ground gets very high. So one of the conditions that is necessary to produce lightning is ice and hail and semi-frozen water droplets, and this is why you come in the northern hemisphere, the possibility of creating lightning is much higher than tropical areas. So what happens to create a lightning bolt? So we have this is the picture for a thunderstorm. So we have upper part and we have lower part, and we have from down to up drift, and from up to down drift. So the up drift takes the water droplets up, and the down drift takes the ice from up because it's colder up, down the down drift. So when these two particles collide, a big quantity of heat is produced, and soft ice, they call it soft hail, so warm ice is produced, and due to this high temperature that is produced during this collision, as this process continues, another further collision happens between the soft hail and the water droplets, and this leads to sudden separation of electrons from the water droplets, and it participated in the ice, which is going down. So charge separation happens in this way. So and as this process goes on, the charge concentration between the upper part and the lower part, the upper part and the lower part of the thunderstorm increases. But the dielectric constant of the thunderstorm is much greater than the dielectric storm of the air, and this is why when the charge concentration in the lower part increases, there is no breakdown occurs here, but the breakdown occurs between the negative charge in the lower part of the thunderstorm and the positive charges accumulating in the ground. So this is another schematic plots for the thunderstorm that can occur between trees. So I have not included any calculation in my presentation because the calculation is a bit very long and not easy. And lightning is now is a hot topic. It's a very good topic of research. So thank you.
Questions? Yep. You talked about the positive lightning and the negative lightning.
Yeah.
Why exactly is the positive lightning so much stronger than the negative one? Why does it depend on the charge carrier?
Yeah, so here we have this when the charge separation happens, this is what we get. So if the negative charge cloud and the positive charge cloud in the ground, this was the main reason for the thunderstorm. This distance is very small. So it's because it travels a small distance, we say that it's of low energy. But when it happens between the positive charges here, and mainly it happens also between a positive charge in another thunderstorm or some negative charges in the air, this travels very long distance, and this is why we say it's more powerful. And this is why positive lightning is around 1% of lightning. And the remaining 99% is negative lightning, because it doesn't need so much energy to happen. Yeah, go on.
Have you looked at anything about ball lightning?
What?
Ball lightning? Ball?
Ball?
Lightning?
What do you mean? Like, what is the question?
It's not understood or known about, not reproduced in laboratories.
You're giving us information, or you asking?
I was
a question?
wondering if you
Okay.
looked at it.
Okay, no.
What about the formation of sprites? What space?
Okay. It's a different phenomenon than lightning, but it happens mainly with an inverse mechanism. It's like the charge accumulation happens on the ground, and because of some charges in the earth, the lightning and the dielectric breakdown occurs because of the accumulation in the ground, not because the accumulation of the charge increases on the clouds. Yeah.
Are you saying that the lightning strikes from the ground?
It's not from the ground. It happens mainly from the top of mountains, some mountains.
I don't think we're talking about the same thing, because the sprites are lightnings that strike from the top of the clouds upwards to the space.
Okay. Oh, so this is not what I was talking about.
I didn't understand why is it the electrons go down and not up? Why, when the charge separation happens,
Yeah.
you know why it's the negative charges that accumulate at the bottom of the cloud and the positive at the top?
Yeah, this happens mainly because of the heat that is produced when the updrift takes some ice from the upper part, and the downdrift, takes some ice from the upper part down, and the updrift takes water droplets from down to up. So here we get a very large amount of heat. This leads to discharge of electrons from water molecules, and it accumulates in the ice molecules.
Okay, so why are the electrons drawn? So I understand the charge separation.
Okay.
I didn't understand, maybe you did just answer this, but why the electrons are attracted to the ice that's going down instead of going up? Why the electrons go to the bottom of the cloud instead of the top?
I've not thought about this.
Okay.
Maybe one more question. So it is said that when people are actually struck by a lightning once, it is much more probable that they will be struck another time. Is there any physics behind that? Or?
Maybe because they will have a higher charge density in their body. Maybe. I don't know.
The question.
Maybe it's a behavior thing.
It might be the behavior, yeah.
Maybe people who are more predisposed to be hit are the ones that were hit.
Okay, let us thank the speaker. Probably not.